Welcome everybody. So today we are going to go through our week 4 concept check part 2. So our second week over ionic compounds. And so our major goal today is to go through ionic nomenclature, be able to handle homework 4. But to do that, we're going to recall some things that we talked about last week in terms of formation of compound and the octet rule. One of the facts that we're going to rely on quite often, again, is that group number is equal to the number of valence electrons. Now, a couple other things to keep in mind, right? We know that metals, which are located on the left side of the periodic table, and keep in mind, right, we're talking about the main group, that they will lose all of their valence electrons. Remember that the octet rule, to get back to a noble gas notation, the metals empty out their valence electrons. Whereas nonmetals, we know, are going to do the opposite, which is they are going to gain electrons. And so the goal is to basically fill to 8. And so if we think about what's going on here, right, we have in group 1A 1 valence electron, 2A has 2 valence electrons, 3 valence electrons, etc. as we work our way across the main group. Keep in mind helium only has 2 valence electrons, but the rest of the noble gases have 8, and that's where the octet rule comes from. So based on the location of the periodic table, we can figure out the charge of any metal or nonmetal. So for metals, right, in this case rubidium, aluminum, calcium, and lithium, if I look up their group number, right, there's rubidium in group 1A, there's aluminum over here in group 3A, calcium's in group 2A, and lithium Li is in group 1A, right, their charge is going to be based on how many electrons they lose. So rubidium has 1 electron, it's going to lose it. Aluminum has 3 valence electrons, it's going to lose all 3 and become 3 plus. Calcium in group 2A has 2 valence electrons, it's going to lose both to become 2 plus, and lithium, like rubidium, is 1 plus. Now nonmetals, on the other hand, right, chlorine over here in group 7A, and sulfur next to it in group 6A, they're going to gain electrons up to 8. So if you have 7 and you need to get to 8, you're going to gain 1 electron and have a 1 minus charge. Sulfur with 6 electrons is going to gain 2 and become 2 minus. So again, we're going to be able to rely on that quite a bit as we work through and deal with ionic nomenclature, which are just made up of ions. The other skill that we're going to rely on quite a bit is making formulas, which we did a little bit of last week. And so the other kind of opposite side of that coin is to pull a formula apart. And so if we cross our charges to get our formula, we can uncross our subscripts to get our ions back. And so if we think about how that works, right, I understand there's an understood 1 here on my copper, there's a 2 on my iodine, and so that 2 we can think of as coming from the charge on my copper, and that understood 1 coming from the charge on my iodine. Now, what you want to do, of course, is be careful and always check your charge on your anion. We always know the charge on the anion, and so we can always check that I is in fact I minus. And we're going to see why as we work our way through. And so in my next example, I have an understood 1 and an understood 1. So I have a 1-to-1 ratio. And so if I were to uncross the charges, I would get Br minus and Ag plus. And it turns out that Br is in fact minus 1. It's in group 7A up here, just like chlorine. But if we look at my next example, which again has understood 1s, so again is a 1-to-1 ratio, if I were to uncross, I would get Mn plus and O minus. But oxygen is up here in group 6. So I know oxygen is always 2 minus. And so here my manganese must be 2 plus to balance it out. So you want to be on the lookout for those 1-to-1 ratios and make sure that your charges are equal and opposite in terms of their magnitude. And so again, that understood 1 on my sulfur comes from my ammonium, which is +1. My sulfur's charge is that 2 on the outside of the parentheses for a polyatomic, and so that would be S2 minus. And so I know that that's the correct charge for sulfide. So most of the time, you can kind of just uncross the charges. And so what I recommend is starting with your anion, right? So go in, write down your anion. Recognize that you have, in this case, a polyatomic. Inside the parentheses is your formula, if there is some. If there's not, just kind of have to recognize it's everything but your first portion. And so you can go in and kind of figure out the subscript on your metal. All of these have understood 1s. And so that would mean that I'm dealing with -1 for all of these. And so I can check, right? It turns out CN minus is correct. OH minus is correct. Nitrate is correct. This is not correct for sulfate. Sulfate is always 2 minus. And so again, with that in mind, right, my magnesium must be 2 plus. Again, this is a 1-to-1 ratio. If you don't have parentheses around your sulfate, that means there's only one of them. Same thing with my CN, there's only one of them. If there's a parentheses, the subscript on the outside came from the charge on the metal. And so here I have K plus, Ba2 plus, and Al3 plus. And so again, one of the things that you're going to want to spend some time on, getting used to pulling apart an ionic formula. We're going to do that lots of times as we work our way through the rest of this packet. So let's move on to naming simple ionic compounds.